All right, so here we go. We're into section 2.1, pre-calc B. Title's called Linear and Quadratic Functions and Modeling. This is about 2 or 3 weeks of algebra packed into one lesson, just getting you ready for Unit 2. So buckle up and let's dive in. So, quick review. Back in Algebra 2, you used to do a lot of problems like this, where it says, find the equation of a line. Now let's stop right there. That's saying y equals mx plus b. Okay? Which means you got to find the slope and you got to find the y-intercept. Now I've worked a little bit ahead, so I wouldn't have to waste your time. But it says of a line passing through negative 2, 2, which is right here, and 4, 1, which is right here. Now as you can see, I got to find the slope and the y-intercept. Now, if I looked at this and I said, oh, I'm going to guess at what that is, that's a bad move, okay? There can be decimals, your drawing can be bad, so there's got to be a different technique. One technique is just to say, okay, this is x1, y1, this is x2, y2, and we're going to use the old formula y2 minus y1 over x2 minus x1 and just plug and chug. So 1 minus 2 all over 4 minus a negative 2. So it'd be negative 1 all over 6. Now, what would the other method be? Take these 2 points, plot them, and then go, oh, okay, slope by definition is rise over run. So I'd have to go down 1, so that's negative, and then I have to go to the right 6, which is positive, and there's my negative 1 over 6. Most people tend to go this way because they don't want to take the time to draw the drawing. So, regardless, your slope is negative 1, 6. Now, how can I find my y-intercept? Well, I'm going to take this formula, y equals mx plus b, it's your slope-intercept form. I'm going to grab one of these points, either this one or this one, plus my slope, and then the only thing left will be my b. So I'm going to do that over here. So I'm going to grab this one, y, that's the 1, equals m, negative 1 6, times times x, which is 4, plus b. Now this is negative 2/3 after I multiply it out, so I'm going to add 2/3, add 2/3. Now I'm going to find common denominators and just make that 3/3. 3/3 plus 2/3 is 5/3 equals b. So I take my slope, I take my y-intercept, and I put them where they belong. So this would be negative 1 6. And this would be 5/3. If you look at it, what's 5/3? 1 and 2/3. It looks like it's in the ballpark. That's why it's nice to give yourself a little visual. All right, now watch. This was Algebra 2. This is pre-calculus, more of a calculus talk. We talk about functions. These are just facts, like the line passes through here and here. Find the equation. This one is more in pre-calc talk because we're dealing with functions. This is a fancy way of saying if x equals negative 2, then y equals 2. Have you seen that before? Right here. What's this saying? This is saying if x equals 4, then y equals 1. It's a different way of giving you a point. This is a different way of giving you a point. You just have to get used to it. Now, I'm not going to redo the problem because it's the same problem. You just need to see that that's all it is. Different way of giving you a coordinate point. We're going to move on. Quick reminder. If you're given these problems and you notice that these two are a match, see that says x equals negative 2, and this says x equals negative 2, guess what? If I was to actually plot those 2 points, negative 2, 6, ding, ding, 1, 2, 3, 4, 5, 6, and negative 2, 3, negative 2, 1, 2, 3. It's just a vertical line, and its name is x equals negative 2. Well, you could have got that by noticing that there's a pair there. Vertical line, remember? X equals, x equals. Should know that by now, no offense if you don't. In this problem, don't you notice that our y's match? So I could be done. I could just say, y equals 6. Done. Okay? Now, if I was to take a visual of this, negative 2, 6, 1, 2, 1, 2, 3, 4, 5, 6, and 4, 6, 1, 2, 3, 4, 6, you can see that it's a horizontal line, and I hope by now you know the horizontal line is always going to be y equals. Just is. Okay? Now, this is an Algebra 2 review. Students don't like it when you're learning it in Algebra 2. It's called completing the square. Now, I'm going to put this in reverse a little bit. This right here is called a quadratic. Hopefully by now you're starting to recognize that this is a parabola. So if you have y equals x squared, you just, aha, that's a parabola. So if I take a look at y equals x squared and I graphed it, it would look like this. Now we've done a few of these in Unit 1. This is going to find my vertex. So that's going to move the vertex left 2, bing, bing. But this is going to move it up 1, so it's going to go up here, and then I redraw it, but then there's another twist. This right here is my A, okay? So that is going to make the vertical, it's going to be vertically stretched by a factor of 2, which means it's going to be horizontally shrunk. It's just going to go screaming up a lot faster, and there it is. Now, here's the thing. That's not really what I'm teaching. What I'm teaching is, how do I take something messy like this and make it look like this to where I can actually graph it? And this is what it's called. It's called completing the square. First of all, rule number 1, this has to be a 1, okay? If this is a 1, which by the way, there are some that aren't, what do? Well, I'll show it to you on the packet lesson. We just don't have time to show you it all now. So what you're going to do is you're going to take this constant, bump it to the right, and so now you're going to have, what's f of x? That equals y, x squared plus 6x plus blank plus 1 plus blank. What did I just do? I moved the 1 over, and I created a couple of squares, a couple of spots. This is slightly different than how you learned it probably in Algebra 2, but it's the same thing. Watch. Do you notice that this is a binomial squared? If I was to FOIL that out, I'm going to do this quickly, it would be x squared plus 4x plus 4. That's a perfect square trinomial. In other words, it's going to be x plus 2 times x plus 2, which gives us our x plus 2 squared, which makes it readable. In other words, we know that we moved the vertex left 2 because it's written like this. See, if I look at this, I don't know where the vertex moves. So I have to use this technique called completing the square, which is just creating a perfect square trinomial. You'll see in a second. So if this is a 1, you go to the middle coefficient right there, and you take half and you square it. What's half of 6? 3. Square it? 9. Now wait a minute. I think of an equation as like a seesaw, a teeter-totter, perfect balance. So you got a 100-pound person here and a 100-pound person here, and you got this little fulcrum in the middle. If I added 9 pounds to this side, all of a sudden it would go like this. So I either have to add 9 pounds to this side, or if I add 9 pounds to this side, I have to immediately subtract 9 pounds from this side. I know in the real world that seems silly when you're talking seesaw, but in a math equation, I added 9, so I got to subtract 9 so that we have perfect balance. That's what that really means. Now look at what I have right here. That's a perfect square trinomial. And if I said, hey, factor that, you'd say, okay, 2 factors of 9 that add up to 6 would be 3 and 3. So it'd be x plus 3, x plus 3. Now you're not wrong by writing that, but that's not what we want. We want this to be x plus 3 squared, and then we take these two, and it's minus 8 equals y. And see, now we have a parabola that we're able to actually graph. It's just in the proper form. So that's where I'm going to stop this pre-lesson. I think we've dug up a whole bunch of really good information, but again, it doesn't cover it all. There's going to be some new stuff coming on the packet lesson too. Ran out of word space and kind of running out of time, so it'll work out.